All right, so I think we'll get started.
Hmm.
All right, hello everyone and welcome. I'm thrilled to be here with you all today. My name is Dan Semenik. I'm a program advisor at the Institute of Holistic Nutrition. Today's webinar topic is recognizing enzyme deficiencies in the eyes, amylase, lipase, and protease. I'm very pleased to introduce our guest speaker, Robert Tomilson. Robert is co-founder of the Institute of Natural Health Technologies, INHT, co-founder of BIE. With 36 years in the field of allergy research, immunology, electromagnetism, biophysics, Robert and his partner, Silvana Fazzolari, operate from the INHT head office in Oakville, Ontario, and conduct bioenergetic intolerance elimination, BIE, training programs across North America. They published 5 books and had multiple TV, radio, media appearances. Robert is a certified iridologist who studied in Europe, Australia, North America, and has been teaching iridology at IHN for over 8 years. He's also a registered nutritional consulting practitioner. Welcome, Robert. Great to have you here tonight.
Thank you very much. I'm excited to be here. Well, thank you for joining us. I'm going to share with you what I'm passionate about. Now, I do have some other webinars that IHN has posted because I do this every year for them. And the first, I think, 3 that I did, they were all basically the same thing, an introduction to iridology. And so I decided we better switch this up again, get them some other different topics to talk about. Last one I did last year was how to identify a fatty liver in the eyes. I could talk a little bit about that tonight, but basically this one's to identify enzyme deficiencies in the eyes. Now, most of you listening, if not all, are nutritionists or have studied nutrition. And it's really helpful to sit down with somebody and just to be able to tell them what your problems are. I could see your problem. So you can have, I could be eating this and this seems to bother me. You can eat really healthy foods and you can still have a problem with that healthy food because you may not have the proper enzymes to be able to digest it. So that's what I'm going to be able to identify. And I'm giving you enough information here tonight that you yourselves, even though you're not iridologists, that you can be able to look in the eyes of your clients, even from couple feet away, and you can tell them what their issues are going to be as far as their digestion. So it's a real simple process that I'm going to show you. I'm going to show you really obvious signs that you can look at in the eyes. What is iridology? Just to give those who are new an idea of what iridology is. It was discovered about mid-1800s. Now, previously that ancient Chaldeans, 2,000 years BC, we're noticing there's changes in people's eyes according to the way he or she lives, sicknesses, anything they're going through health-wise, and they can see different changes in the sclera, which is the white part of the eye, because the blood vessels are pointing to different areas in the eye. And so the shape of the actual blood vessels actually tells you the pathology, what's going on. And they noted this, even as far as later in the Yellow Emperor's Manual in the Ming Dynasty, they actually have drawings of different people's eyes showing the blood vessels and where they are pointing to in different parts of the iris that could pretty much give a good estimate of what's happening in somebody's body, any sicknesses or imbalances in the body. And it wasn't until a Hungarian doctor that worked in, he was working in Germany, I think at the time, but Ignaz von Pexley, he worked in a college hospital, and that afforded him the opportunity to take his scope. And you've seen many doctors, they'll come up to you with a scope like this and hold it up to your eye, and they look in the eye at the back of the eye at the optic disc, the optic nerve, and the retina. And they have an overall idea what's going on in the body, but they neglected to look at the most important part of the body, which is the blue and the brown part of the eyes. And that is that iris, or the irids or irides, that's the proper plural name for it, irides. They are millions, or I should say thousands and thousands and thousands of nerve fibers known as trabecula. 65% of all the nerves in the brain travel through the eyes, through the irids or irides, and they knit the bundles Let me see if I can actually show you a picture of it. So this is a map that I put together for students, but I'm not the creator of the Iridology chart, but you can see, if I can blow this up, no, I can't. Oh yes, I can. So you can see there's different zones to the eye that represent different organs in the body. And so what they discovered, Ignaz von Pexley discovered, he says, well, if I see a problem in this, the fibers actually start to split open, different places in the eye, and they start to split open. That means there's an area of weakness in that area. I won't get into the details and bore you. You can look at some of my other webinars, and I explain the basis of this and the beginnings. But once they discovered when there's a weakness in the body and the fibers will split open, see what's happening is 65% of the nerves in the brain travel through the eyes, and they knit these bundles. And then they leave the optic nerve, optic thalami, down the spinal cord to the organ of the brain, or the organ or the tissues in the body. And then it goes back up the spinal cord to the brain, then through the eye. So there's a continuous loop of nerve fiber. So anytime there's a problem in the body, whether it be a subluxation, which is a pinching of a nerve, disease, atrophy, injury, inflammation, something happening within the body, some pathology, it tells the brain, which tells the eyes, and they can tell what part of the body was affected based on the map here. And so I'm going to go through a few things with you, but more in the form of, like I was saying, to be able to tell you what enzyme deficiencies there are and how you can tell them from the eyes. All right, so the first one we want to look at right now is amylase deficiency. Now, amylase is an enzyme that breaks down complex carbohydrates, which is starches, into simpler sugars during digestion. It's produced primarily in the saliva and the pancreas. Most of you know this, but I'm preaching to the choir here. So this is indicated in the eye by the orangey color. See, that's not a true eye color, is orange. As we would call it, it's probably hazel. When we look in an eye and even 3 feet away and you see this orangey color that looks like hazel. A hazel eye means they're usually deficient in amylase. Not always, but usually. So if I see that orange in an eye, that usually is an indication that sucrase, isomaltase, maltase, lactase, those are basically in the family of amylases breaking down sugars. And so those break down sugars for better absorption in the gastrointestinal tract. But if you see that orangey color, you know they're going to be lacking one of those enzymes for digesting sugars, simple sugars, things like that, carbohydrates. They do not do well with carbohydrates. And a deficiency in amylase is linked to metabolic issues like diabetes, high triglycerides, obesity, and insulin resistance. So how does that work? Well, let's say this is sugar floating around the bloodstream here, and the pancreas is over here, and the brain tells the pancreas, hey, there's sugar floating around here. So the pancreas releases insulin, and insulin grabs a hold of the sugar, literally converting it to fat. It actually converts the sugar into fat and puts it in the receptor site. However, for some reason, if your body's not metabolizing sugar properly, it makes it more difficult to get in the receptor site. It's not closed completely like they're diabetic. It's harder to get in. And so what it requires is the pancreas producing more insulin to say, basically, get in there. So the pancreas actually produces more insulin to push the sugar in the cell. Now, because the insulin is a fat-storing hormone, the more insulin that's secreted, the more fat it's producing. And similar to that, insulin is like battery acid. It's a really acidic and very inflammatory hormone, but most people don't realize that. So the more insulin your body produces, the more inflammation you get. The more inflammation you get when tissue is exposed to acids, let's say, everything shrinks in to protect itself, including the receptor site. It starts shrinking down, and that further produces more of an issue. So it's a downward spiral. Now your pancreas is going to have to produce more and more and more insulin to keep punching the sugar in the cell. and that creates further more inflammation in the body. So what happens is, as soon as that sugar that the insulin grabs and converts it into fat starts building up in the bloodstream. It's like if you turn a tap on and it goes to the drain, but the drain is slightly clogged, so the water starts filling up in the sink when you turn the tap on full. Now it should just be going straight down the drain when you turn the tap on. But if it's slightly clogged, then it starts filling up. And that's basically what can happen inside the body, where the sugars that you're eating, say let's you eating a lot of sugar, and I'll get into that in a sec. So if you're eating a lot of sugar, that sugar gets converted into fat from the insulin. But if it's having a hard time getting in the cell, it backs up. Now the liver is looking at this and saying, wow, that's a lot of fat building up in my bloodstream. I better break some of this down. So I'm going to take it in and start to break it down. If the liver can't handle the amount of sugar that's going in your body, then it says, wow, well, if I can't break down the fat, I'm going to have to store it. So the liver starts producing cholesterol. I think there's a couple of heart institutes that have published that, correct me, I don't know the exact name of the extra institutes or the organizations, but they said no amount of dietary cholesterol will really raise the cholesterol levels. The cholesterol is caused from eating starchy carbs or sugars that convert into fat, and then the liver produces the cholesterol to help to bind to the fat and break it down, store it. So the cholesterol goes up because you're not breaking down sugars or fats properly. So this is the important thing. When you're looking at an eye and I see out that orange, I know that that person is not going to metabolize sugar properly, and that's going to end up with an issue with building up too much fat. Now, I will tell you in another slide a little bit later when it shows how you start getting a fatty liver and what to identify for that. So it's very important that when people have a sugar metabolism problem, they should cut down on some of the sugar. Well, I don't eat much sugar, people say. They'll sit right across from me and say, I don't eat much sugar. No, there's typical guys, I don't eat sugar. Do you drink beer? Oh yeah, I love my beer. Well, one can or one bottle of beer is equivalent to about 16 teaspoons of sugar once that starch from that one beer is broken down inside your body. 16 teaspoons of sugar, that's a fair amount. So that's going to require a lot of insulin, get that in there. Now, how many love bread? Oh, I don't eat sugar, but I'll eat bread. Okay. Let's take a normal sized piece of bread and break the starch down from one piece of bread into sugar in the body. So as the amylase breaks down that sugar, converts it, maltase specifically is an enzyme that breaks down maltose from the starch from the bread. And it converts it into about 2.5 bowls of ice cream worth of sugar from one piece of bread. Did you hear what I said? It's not that they're putting this much sugar in the bread, but the amount of starch that's in one piece of bread, when that breaks down into sugar, you get about 2.5 bowls of ice cream worth of sugar. It's one of the highest glycemic foods you can eat is bread. Well, I don't eat a lot of bread, but I eat a lot of pasta. Okay, let's have a plate of pasta. That's like having about 5 bowls of ice cream. And 2 pieces of bread, 5 bowls of ice cream. So, an average potato is about 8 teaspoons of sugar per potato. So there's a lot of starch that we eat. And the starch needs to be broken down. If you have this orange in an eye, you know you're not going to be breaking down that properly. So one of the first things I tell the nutritionists that come in, I said, just make sure that you're talking to, when you see orange in your eye, they've got to switch to more of a ketogenic diet. And I don't mean necessarily you have to be keto or whatever, but just cut down on your carbs. You're not digesting them well. All right. Now, let's go to the next one. So remember, orange in the eye means usually you have an amylase or maltase lactase deficiency. So I want to show you this chart here. Now, in the center, you're going to notice there's this jagged line around here. This represents something called the collarette, or the autonomic nerve wreath, if you've been trained in North American iridology. It roughly lies about 1/3 of the way out from the pupil to the edge of the iris. And it goes fairly round, And if I went back to, oh, I just want to say first off, so on the inside of that is the large intestine, the small intestine, and the stomach. So that's all on the inside of that. So if I went back to this previous slide, here it is. I'm going to show you here. It's very hard to see in this one. It's very faint, but you can just barely see the outline of that. And it goes out to here. You can see it up across the here. So you can see that's the outline. Now on the inside is the stomach and the intestines. On the outside is the rest of the body. This is called the pupillary zone, and this is outside is called the ciliary zone. But you'll be able to see this easier on this next slide. Now, do you see this one? See the jagged edge going around? It should be, like I said, a third of the way up from the pupil to the edge of the iris. But now to notice this pulls in closely down here. It tucks in, goes out a little bit, and it seems to be touching this zone. Now, I don't know if you can just barely make it out. There's a bit of a halo right here, just the edge of the halo. And that's the stomach zone. Let's go back to that chart and you'll see this. See, that's that stomach zone here, right? And that jagged line should not be touching the stomach zone. It should be out here. But looking back at this, it's not touching here. There's the edge of the stomach zone, the stomach halo, and this is out here. And then it comes in, boom, it touches the stomach. If that jagged line, which is the collarette, and that supplies the nerves to all the tissue in the body, if it touches the stomach, even in one small spot, then that person has now a nervous stomach. Nervous stomachs tend to have a problem with digestion as it is. So I won't have to talk about that too much, but I may talk about it a little bit later. But you notice it's usually more deeply pigmented in here. It's darker. The previous slide here, you can see it's more pigmented in the center. That means that's usually more, that this orange represents toxins in the body. And the toxins in the body, they are clear when they go in, but they tend to change colors, specifically different emotions we go through. And I've spent time talking about this in previous webinars. I'll touch on it very quickly. Every time you go through a different emotion, there's a part of the brain called the hypothalamus that releases these chemicals called neuropeptides. And when the neuropeptides mix with the toxins in the body, which are clear, they will actually change the color of that toxin. So studies and research has shown that you'd be able to tell a person what they've been going through emotionally based on the color in the eyes. So when we see a lot of orange in the eye, that usually is an indication that they've had a long-term lack of joy in their lives that has actually caused this orange in their eye. I don't need to get into details with people. I just say, listen, I don't need to know why you're lacking joy, or had been, but that's permanently stained now that you're looking at that orange in here. But you've gone through a lack of joy in your life. So, but that same neuropeptide that turned that orange starts to affect the pancreas. This happens to be the pancreas. Not here, pardon me, not in this eye, but the next one I'll show you. But it can affect the pancreas. And so that pancreas helps to balance the blood sugar. If I see yellowy color, there's some that are actually more yellow, but there's a little bit of a yellowish color here. And the yellow color is typically someone who has experienced fear, worry, concern, anxiety. So this different neuropeptide mixes with the toxin, turns it yellow. And that same neuropeptide that turned that yellow starts to affect the adrenal glands. And once you now have the orange from the pancreas, the yellow from the adrenals, those two things help to balance the blood sugar. There's a little brown spot right down here. This is a little pigmentation spot, and it's called a hyperpigmentation or a SORA spot. And that's an indication that this person has some kind of a medication when it shows a little spot like that. But why is it brown? Medication didn't go in the body brown. It's because they experienced the emotion of anger. This doesn't mean this person's an angry person, but they had gone through anger. The neuropeptide was released, mixed with the toxin, turned it brown. And then that same neuropeptide that turned that brown starts to affect the liver. Well, now that's interesting. Orange, pancreas, yellow, adrenals, and brown liver. Those are the three things that balance blood sugar levels in the body. So if I'm looking at orange, or I'm looking at yellow in an eye, or if I'm looking at a brown, not a brown eye, but brown in a brown eye or a brown in a blue eye, then I know that that person struggles with metabolizing sugar. But again, getting back to the enzyme deficiency, when I see orange in an eye, I know they will have a problem metabolizing carbohydrates. So just so you know, they have to cut down on their diet and a lot of carbohydrates. So let's look at this next one here. Now, the next one is protease. Protease is an enzyme. This basically pepsin, trypsin, and chymotrypsin is basically they're basically in the proteases. Protease is just a generalized term, but pepsin, trypsin, and chymotrypsin specifically break down proteins in the small intestine. They're produced in the small intestine, but they break down and proteins into smaller proteins called amino acids. Now, studies suggest that they improve digestion, which they would. You're breaking down protein. They decrease inflammation and ease arthritic pain. Now, if you are lacking in protease, you have this whitish look to the eye. You see how gray that looks? This is a blue eye, but it looks like an icy blue eye. So let's look at this next picture. See this eye? This is a true blue or lymphatic iris. That's a true blue. It looks like a blue jean blue. That's the color of a blue eye, what it's supposed to be. However, when you have a lot of inflammation in the body, it makes the tissues inflamed and they get white like this or grayish look. A bluey gray eye is an indication of a person who is lacking protease enzyme. It also shows they've got a lot of inflammation. The more of the white there is or the gray, the more inflammation they have in the body. So this person is very prone to arthritic conditions, any kind of inflammatory bursitis, tendinitis, whatever it would be, itis, inflammation of different parts of the body. And so that's what we're looking at. When you look at an eye and you see a really icy blue eye, you know that they're typically lacking protease enzyme. Sometimes just supplementing with a protease enzyme is really, really helpful. But it breaks down proteins into smaller polypeptides, or amino acids, which is basically the basic building block for all proteins anyway. And what's very typical when you look in an eye and you tend to see that halo. Now let's see if I can see a better halo here. No, not that one, not that one, no. So it's not always easy to see. No, not even in that one. But sometimes you can see this halo around here. And usually when you see a halo, that's usually a good indication that somebody has a problem with amino acids, meaning their body's not breaking down proteins properly. It really, this halo in the stomach just tends to say, well, you're lacking hydrochloric acid. And if you're lacking hydrochloric acid, you're prone to getting gas and bloating, certain things you eat, et cetera, et cetera. So a halo usually means they are lacking some kind of a hydrochloric acid, but it usually also indicates that you usually have a problem with breaking down amino acids, which is proteins. So in a nutshell, if I'm looking at a gray blue iris like that, that means, or the more the icy blue you have in an eye, the harder harder time they have breaking down proteins. Typically, this person will have a hard time breaking down grains or dairy products or grains. This person will usually have a problem with. So looking in that eye, you'd say, I would be very careful on having so many grains. And I don't mean greens. I have to say grains, as in wheat and oats and barley and all that kind of stuff. It's just they tend to break down. They can't break it down properly. So anyway, that is how to identify if you have a protease deficiency. So maybe a protein enzyme will help, protease enzyme that'll help to break that down. Okay, so let's go to the next one. I don't need to make this a long talk, so I just want to give you the basics. That will open up some more room for some questions at the end if you have any. So now, this is the next one, a lipase deficiency. This is an interesting one. So lipase is an enzyme that breaks down fats during digestion into smaller molecules called fatty acids and glycerol. Deficiency can prevent the breakdown and absorption of vitamins like A, D, E, and K. Those are fat-soluble vitamins. So if you're not breaking down fats, you're not going to have an easy time breaking down A, D, E, and K, which are the fat-soluble vitamins. So lipase is often a result of the body's inability to properly digest fat, which include abdominal pain, diarrhea, fatty stools, nausea, vomiting, bloating, and unexplained weight gain or loss, oily skin, and cognition issues. The oils are a big part of our diet. We should be having plenty of good fats, not bad, fried foods and things like that, but you know them. You're all nutritionists that are listening to this. Your olive oil, virgin olive oil, coconut oil, avocado oil, good oils like that. Really, really good. A lot of them are full of polypeptides, especially the olive oil. Such a good oil. And we need to be able to break them down. They're so important for the health of the body, as you know. But how do you identify that? Well, do you notice this blob against the side of the eye here? See that? That's called a pinguicula, and that's indicative of a person who's not breaking down fats well. Now, if it's a yellowy color, and it's kind of yellowy in there, they have an issue with more of the liver, more of a liver issue breaking down fats. If it's clear, like a clear blob, that usually means gallbladder issues. And if it's white, it usually means there's a vitamin A deficiency. Well, because they're not breaking down fats, so vitamin A is going to be part of that. So this eggshell white here means they're not breaking that down. But this whole overall, the whole pinguicula here is indicative of this. They're not breaking down fats properly. And so that means they usually are low on lipase. They don't have enough enzyme to break it down properly. And there's a really great thing that you can do. You can take 2 tablespoons of, if it gets this bad, that is, but you can take 2 tablespoons of extra virgin olive oil, 2 tablespoons of freshly squeezed lemon, and 2 tablespoons of apple cider vinegar. And you drink this on an empty stomach every morning, probably for about 2 or 3 months. And it pretty much takes care of a fatty liver. It literally turns it around. I've seen many people that have gone, they got tested and they said, you got a fatty liver. You give that to them, they drink this for 2 to 3 months, go back and they said, oh, your liver is actually doing really well. It's no longer a fatty liver. So just FYI, I might as well throw that in there, but that's a good thing. But here's something else I want to identify. Look at this haze around here. Do you see that? This opaque haze. You didn't see that in the other eyes. What that is this zone right here. Now that's that red zone you're looking at here, which represents the circulatory or lymphatic system. The circulatory, it's right in here. And this surrounds the whole body. So it basically says the circulatory system they have hardening of the arteries. Whoops, pardon me. I'm going to go back to that one again. So it's hardening of the arteries, which causes this. Now, that can usually be, it can be hardening of the arteries from fats and triglycerides and cholesterol and fiber and whatever. But it also can mean they have a problem with calcification buildup. But here's what you look at. If you see this white opaque ring, you usually see that in elderly people. If you see the white opaque around the periphery of the iris and the pinguicula here together, you know that that's usually a cholesterol issue. Now, we're not allowed to diagnose you've got high cholesterol. You have to go to your medical doctor to get that test. However, that's usually a very good indication that they are not digesting their fats, triglycerides properly. So the liver is working extra hard now to break down the fat. It actually produces cholesterol to bind to the fat and break it down. This is also one I want to show you here. You may not see that from the naked eye, just looking at them from 2 or 3 feet away. But there's this brown ring in here. Do you see that? That's called the assimilation ring in the eye. And let's see if I've got that on a picture here. No, maybe not. I'll go the other way. Pardon me. So that's this orange zone right in here. See that? That's the assimilation ring. And that is indicative of a person who is does not have enough, their liver doesn't have enough, pardon me, what am I thinking about? Lipase. I'm just trying to blank here just because I'm put on the spot. Um, Lecithin, pardon me. I don't know why I couldn't think of that. So the liver is not producing enough lecithin to help break it down. So what's lecithin? Lecithin is very similar to dish soap. So if you have a greasy frying pan and you just fried some fatty bacon or whatever it would be, none of you eat that, right? So I'm just saying, kidding. So you finished it, you put it in the sink and you left it overnight. That bacon fat is going to be hard and white and hardened onto the pan. So what do? Do I just take a scrub pad and just scrub it? No, it's just going to move it around. It's not going to get rid of it. Um, I'll just run it underwater. Well, the water's going to hit it and bead and run right off of it. You need soap and water. The soap is an emulsifier. It breaks up the fats and it loosens it up and lifts it off the pan. And that's basically how you would clean a pan. Well, your liver needs to use lecithin to break down the fat. And when you see that ring there, that means, well, the liver doesn't seem to have the lecithin anymore. Uh-oh. Well, if I can't break down the fat, I'm going to have to store it. So the liver starts producing cholesterol. And the cholesterol was going to help to break down the fat and bind it and store it. So you usually see that ring when you see this pinguicula here, or this is a corneal arcus, what we call it, around the iris like this, the periphery of the iris. So that's when you see that, you know that's usually a result of they have a problem with lipase deficiency. Okay, so low lipase is as a result of the body's inability to properly digest fat and include abdominal fat, diarrhea, fatty stools, and like I said earlier, cognition issues. These are all the symptoms typically that happen when you can't break down fats properly. The cognition, yeah, you need fatty acids to fire properly. Otherwise, you have a short-term memory loss. And this is the brain right here. So let's go back to the chart here. So this is the brain between 11 and 1. If this was a clock going around here, these zones between 11 and 1, this is all the brain. So now going back to that, this saying right here, this is the blood vessels to the brain. And so when they're congested, the first thing that goes is your memory. Cognition, memory, it's gone. This doesn't mean you have Alzheimer's. It just means you have a hard time remembering things, and your cognition isn't as sharp as it could be. If it gets bad enough, I always joke about this, but you can hide your own Easter eggs after a while. You can't remember anything. You walk into rooms and go, now what the heck was I just coming in here for? That's very typical when you see this. So I just wanted to show you the three basic enzymes, the amylase, the protease, and the lipase. And those are how you can identify it without being an iridologist, but you can identify it just by looking at that. So it doesn't have to be a brown eye or a blue eye, as long as you see the white ring in here and you're looking at fats on the actual sclera, on the white part of the eye. So that's how you can tell if it's a lipase deficiency or not. Now, this is a hydrochloric acid deficiency. I was talking about this, about the ring around here. See that ring? It's a very sharp ring. And that's the stomach zone. And when it's a very pale halo like that, very faint, that's usually indicative of a low hydrochloric acid, hydrochloridia. And it's a condition characterized by low stomach acid production, which can lead to digestive issues and nutritional difficulties. Well, no kidding. You're not breaking your food down properly. Symptoms may include bloating, gas, and indigestion, and prolonged low acid can cause brittle hair loss, fatigue. Why? Because you're not getting the nutrients. You're not breaking your food down properly to get the nutrients out of it. B12 deficiency. We're seeing a lot of that lately. So many people coming in on a daily basis in my clinic saying, I have a low B12. I'm really deficient in B12. Well, their digestions are messed up. And causes can include H. pylori infection. Helicobacter pylori, and it has been associated with conditions like gastroesophageal reflux disease, GERD. And so this is very common. You'll see this in a lot of people. I want to hear some really interesting fact about this. So this was a study by a gentleman by the name of Denny Johnson. He did 20,000 clinical case studies, and he interviewed 20,000 people, took photos of their eyes, made them fill out long, extensive questionnaires on their likes, dislikes, their health, habits, whatever, entered them in the computer. And basically the computer lined them up under the eye patterns. And so this ring they call the ring of perfection. So that ring around here represents the stomach physiologically, which represents low hydrochloric acid when it's a pale halo like that. See, the fibers out here in the ciliary zone are very bright, but this is really a dull halo. So that means under acid. And so they noticed that the low stomach acid like this, or that ring, meant physiologically low acid, but personality-wise, he says that's called a ring of perfection. This is a person that is a perfectionist. They like things just done properly and accurately, done right the first time. They like to be on time, and they have to be everything lined up and neat. This is this person. And they also like to teach people things they learn. I learned something new. I'm so excited. I want to show you what I just learned. They love to teach. And it also indicates this person has a hard time digesting life. You can take this to the bank. It's actually quite accurate. And out of 30 some years I've been doing this, it's quite accurate. And so I can tell this person, they'll giggle and they'll say, how do you know that about me? That's just me. Okay. Now, conversely, this is another halo, but this one's really bright. This bright halo in the stomach zone is brighter than the tissues out here. So when it gets really bright like this is a hyperchloridia, which means an overproduction of hydrochloric acid, which can cause symptoms of heartburn, acid reflux, nausea, abdominal pain, diarrhea, and belching. While sometimes in normal variation, it's also often associated with ulcers and can be linked to factors like H. pylori infection. The body senses this Helicobacter pylori bacteria. It floods that area with hydrochloric acid trying to kill off that bacteria. So you tend to get this ring in here. And this is also, it can be caused from having NSAID drugs, non-steroidal anti-inflammatory drugs, a lot of coffees, pop, sodas, things. And that can actually cause a hyperacid stomach. However, it still represents a person who is a perfectionist. They like things just right, so they like to be accurately on time and do everything neatly. They also like to teach people things they learned, and they love to also, they have a hard time digesting life. That doesn't mean they're not happy. It just means they have to deal with the hand they've been dealt in life, with all the troubles that go with us in life. And that when the harder time you have digesting life itself, there's a nerve between the brain and the gut. It's called the vagus nerve. So whatever you go through here, the gut is like the second brain. It sends a signal to the gut, and you get nervous stomach, or you get gastrointestinal problems just because of all the stress. So, when someone has that ring there, it's usually because they're expecting perfection in life and all this trouble's going on. And well, that's what happens. And then you start getting this problem with either an excess stomach acid or a deficiency. Again, excess is a bright halo, and hypoacidic stomach, a less acid, it turns out to be a very pale halo. Okay. And let's see. That's pretty much my talk. It was a shorter one. I just wanted to go through those basics with you. Now I think we can just open this back up for discussions. If you guys have any questions, I'd be more than happy to answer any questions.
Yeah. Thank you so much, Rob. That was amazing, truly enlightening and fascinating. And I just love how this ties back to the idea that eyes truly are windows to the inner terrain, especially when it comes to enzymes, which are the spark of all life processes.
I thought you were going to say it's eye-opening or something corny like that.
Not this time. So now we're going to open things up for a Q&A session. Everyone, please feel free to type any questions you have for Rob in the Q&A section. or in the chat if that's easier. And we'll take a few moments to go through what's come in and answer as many as we can.
If you're like me, it takes me a long time to type anything. So just one sentence.
Oh, okay, we have one from Lacey. Do different colored eyes represent anything in particular?
Yep. Typically, but not based in stone. So you can have a blue eye, a lymphatic eye. They typically have problems with dairy or grains, not greens, grains, but not necessarily. If you have a brown eye, a true brown eye, looks like a deep chocolate brown eye, they typically have a problem with proteins themselves as well, but not necessarily. They'll also have a problem breaking down sugar. And also the first eye the first eye I showed you, it's what I call a hazel eye, or what's called a biliary eye in iridology. That's indicative of a person usually has a problem with dairy or sugars. So you can have a blue eye with a problem with dairy and sugar. You can have a brown eye with dairy and sugar. You can have a hazel eye with a problem with grains. But that's typically what happens. Blue eye, dairy, and grains. A hazel eye would be more sugars, and a brown eye more proteins and what have you. But so that can vary, but yeah, so it's a good place to start anyway.
Thanks, Rob. Another one here from Bridget. Can this be done remotely, or do you have to see someone in person?
No, as long as you can send me a decent picture of an eye. Here's the problem. People they'll hold their phone up and take a picture of their eye, but they're standing against a window to get enough light in the eye. I would prefer that not happen. Go in a darkened room, take a photo of your eye with a flash, and if you hold the flash maybe 8 to 10, even 10 inches away from your eye, and take a photo, or have someone take a photo, and a flash will only show up, the flash will only show up in the pupil. But if you're standing against a window, you get all this glare, and then I can't see the iris fibers. So if someone does do let's say you win this, and you're at a distance and you want to send your picture, and I can do it over the computer like that. I can put it up so we can both walk through your own eye, but it has to be fairly clear. So you might have to take a few photos to get a nice, clear, sharp one, and then send it in. So yeah, if you came in here, I would take a proper photo with a good, proper iridology camera, and then I give you those photos to keep, and then we walk through your own eye in the session. So you can do it remotely or in person.
Brilliant. Thanks, Rob. Can you repeat, this is from Andrea, can you repeat what you said about what to drink for fatty liver?
Yep, that's 2 tablespoons of extra virgin olive oil, 2 tablespoons of fresh squeezed lemon juice, and 2 tablespoons of apple cider vinegar. You do that, mix it together, and drink it down on an empty stomach every morning. In about 3 months, 2 to 3 months, that should pretty much take care of a fatty liver. It works wonders. I've known hundreds and hundreds and hundreds of people that have gone through that, and they get this great glowing report afterwards that their liver is not fatty anymore. Can't guarantee anything, but that's been working for a lot of people for a long time.
Very interesting. Very interesting. Delia says, great webinar. Thank you so much. Agnes asks, it's fascinating. How long does the changes in the eye take? Example, after having a junky meal or after several years? When someone improves their diet, how soon can you identify improvements?
Oh, I have great pictures before and after 6 months. Now, it can show improvements before that, even within a month, but it's more, they're very, very slight changes. So your health will improve. Your symptoms will disappear very quickly within a couple weeks. However, the eyes will start showing real concrete evidence there's a change within 3 to 6 months, especially 6 months. And I've got a lot of pictures before and after 6 months later, and they're quite shocking. Wow, what a change when they drastically change their diet. 15 months ago, I went off sugar. I started noticing there's a problem in inflammation in my leg. I got a blood clot in my leg, and I went, why? I didn't get the COVID shots. I didn't. What's happened? Why did I get this? So I developed this blood clot, and I just happened to have a piece of ice cream cake. It was my daughter's birthday, and she wanted ice cream cake. So I had a piece, and the next morning my legs swelled up. So I didn't know if there was any kind of correlation to the ice cream cake, but I said, you know what? No more sugar. So I cut sugar out to the point where I was really, really anal about it. I don't know what to say. I was reading, if I was having some organic non-GMO popcorn and it had a little bit of cheddar flavor or something, and then my partner says, Rob, this has got sugar in it. No, it's not. There's no sugar in the solid. It's not sweet at all. Read the label. So I'd be reading down the labels way, way down there. No sugar. I mean, it says it's got sugar in it. Can't have that. So this is how I've been. I haven't had sugar for 15 months now. And I tell you, I feel great. Now my eyes look different. They look really blue. And you can't tell from this picture, but if you look closely at my eyes, they're really blue. And they were hazel. So they really cleaned up just from not having sugar. So it takes some time, but typically you will notice a big noticeable difference within 6 months.
Perfect. Thanks, Rob. A few more questions here. Also from Agnes, does the iris analysis usually align with symptoms and blood work? Are there circumstances when there is a discrepancy?
Sometimes there's discrepancies, but a lot of times, most times, they will align with it. You say you have a problem. Now, we can't see levels of something in an eye, but many doctors, I actually have worked with many doctors, clients of mine that come in here, and they'll say, yep, that's right, that's right. I was saying earlier, I had a cardiologist come in, and I told him just what I saw. And he says, that's bang on. That's just scary how accurate it is. You said I had a fatty liver. I do have a fatty liver. And you said I had this problem. I do have a problem. You said I have a problem with my left knee. I do have a problem with my left knee. So it does line up with a lot, but it can't tell you whether you have levels of hormone in the body or whatever. That has to be done through your medical doctor, through blood tests, urine tests, whatever they want to do with you. But so we can't see levels. We can just see that there is a deficiency in some of these things. So it should line up. If you have a deficiency in amylase or you have a deficiency in lipase, it usually is right with the blood test.
Thank you, Rob. Harry asks, once these deficiencies are corrected, is it possible for the eye color to revert to its original appearance?
Surprisingly, yeah, I have seen cases where I had a lady come in. She says, no, and her daughter was with her and says, no, you wouldn't believe this. I used to have brown eyes. Now mine are blue. And this is only within 6 weeks. Now, I'm not saying if you have brown eyes, they'll go blue. I'm not saying if you have blue eyes, they'll go brown. Her eyes were supposed to be blue, but she had so much toxin in her body. When it cleared out, her eyes went blue because all that brown toxin and muck started clearing. So that's only happened once where it went from a brown eye to blue. And the daughter says, I'm right there. I am a witness to this. I've seen her eye change. I can't understand how her eyes are blue. Now, most times they don't change that dramatically. They will show eye color changes. Like my eye was really hazel. Now it's a bluey, almost a bluey green eye. So eyes do change. But if you have a true brown eye, it'll always be true brown. If you have a normal blue eye, it'll always remain blue. But it's the toxins that clear that show the actual changes in color. That makes sense.
Very good. Fuang asks, how can you see amylase deficiency in someone with brown eyes?
That's a good question. It's harder to see. And that's why I showed mostly blue eyes here. It's not because we're trying to leave out the brown-eyed people. It's just that blue eyes, you can see colors more so. If you have a brown, here's a general rule of thumb. You don't always see the color changes in brown eye unless you've got a good camera and you can take a nice clear photo and blow it up. And you can see variances variations of color within the brown. You don't have that necessarily. So here's a general rule of thumb when you're looking at a true brown, deep chocolate brown eye. Who's a deep chocolate brown eye? Asians, typically, West Indians. They usually have these dark brown eyes, very beautiful eyes. And usually with a hematogenic eye, that's what it's called in iridology, hematogenic, it usually indicates they will have some blood sugar metabolism errors and some protein problems breaking down proteins. So you don't necessarily see the colors, but if you have a true brown eye, generally they will struggle with breaking down. Doesn't mean diabetic, doesn't mean they're going to get diabetes, but it typically means your body has a struggle to maintain proper blood sugar balance, and also it has a hard time breaking down proteins. Typically, also with a true brown eye, they will usually have issues with liver or detoxifying the liver and cleaning the colon, because their colons usually will have a problem with slow colons or not moving toxins out of the body fast enough through the liver and colon. So that's a typical general rule of thumb when looking at a true hematogenic or brown eye. Again, I hope that answers your question.
Thanks, Rob. Mark asks, could lime juice work in place of lemon for the fatty liver?
Yes, it can.
It can. Okay, great. Lacey asks, can you clarify what the true eye colors are? For example, is green considered a true eye color?
No, it's not. There's true brown, true blue, and genetically mixed called biliary. A green eye, very pretty, by the way. A green eye is a blue eye with yellow toxins over top of it. So if you put a yellow toxin over top of a blue eye, you get a green color. If you put a orange toxin over a blue eye, you get hazel. You see? So, but if it's spread orange throughout the whole eye, that's called a biliary eye. But brown, biliary, or blue, and that's it. But everything else, the greens and stuff like that, and greeny hazel or whatever, those are just toxins that make it look different colors. Like I said, yellow over top of blue makes it look green. That's not a proper color. I mean, because not a true genetic color, that is.
Okay, Rob, looks like we have one more question, and then we're going to spin the wheel for the winner for that 1 hour meet up with you. So Agnes asks, do you have to take a different approach to analysis depending on eye color? Is it easier or more difficult to analyze blue versus brown, for example?
If you have the proper camera, it's no problem doing a brown at all. It's easy. It's lighter when you have a blue eye, so it's easier to see the different variations in iris structure, be it the trabecula, which is all the nerve fibers of the eye. And it's easier to see because you can see more light coming from it. But a brown eye, you just have to include, see, I have this camera, it's a specialized camera that takes a photo of it. But then once I put it on my computer, I can lighten it up. I can brighten up the photo, then I can see the details. So it is a little more difficult to see a brown eye, but with the right camera, you can see all the things you need to see, just like you would with a blue-eyed person.
Okay, so we'll do one more follow-up question to that because then we're getting close to 8. So Andrea asked, are there no green eyes without toxins? When you see green eye, yeah.
You can have, the toxin is yellow and the yellow on top of green. Now you can be pretty clean on the inside. But in order for it to be green, there must be some yellow toxin. Not a lot. Doesn't mean you're a toxic person if you have green. It just means you had toxin at one time, and the neuropeptides that are released from the hypothalamus, it's stained. It's like having a stain on it. And you stained that color and it turned yellow, but now that yellow color is permanently stained on the blue eye. So you can be clean as a whistle on the inside, but the eye is permanently stained that color. It can fade somewhat, but usually not 100%. And if you are a worrier, so let me explain that. If you have a lot of anxiety, your body is constantly producing this neuropeptide that turns the toxins yellow. So any kind of toxin in your body tends to go yellow. So you'll continually see this greeny color. That's why, ladies, if you're crying and you got blue eyes and you're crying, often you'll see you've got a greeny look to your eye. It's usually fear, worry, anxiety, or something like that, and it tends to turn that color yellow. So, but it doesn't mean you're a very toxic person at all. So I wouldn't worry about that. I don't want to panic anybody thinking I'm toxic. I eat so well, but it's everybody has a little bit of toxin in their body. It's pretty hard to avoid that. You're breathing it in. You're drinking toxins when you drink any water, basically. You're eating toxins in the food. It's from the soil. So you get these toxins in the body. And if you're not having enough bowel movements and you're not pushing things out fast enough because you don't drink enough water, you don't have enough fiber, you'll accumulate toxins over time. So it doesn't mean you're a toxic person, but then you'll have some toxin in the body.
Super. Thanks, Rob. All right. Thank you, everyone, for those great questions. And Rob, thank you again for those thoughtful answers. Sorry. Just to mention a bit about the Iridology course that Rob instructs. So the C.IR designation given to each student that passes the course exam is used to give credibility to their clients and show they have extensive training in the study of Iridology from a recognized institution. The Iridology methods that are taught in the course are recognized in any country where Iridology is practiced. So next one, Rob, is February 2026. The format is online live on Zoom. There's 16 Tuesdays, so that's 48 hours in total, starting February 10th to June 2nd. Is that correct?
I think that's right. Yeah, I don't know exactly the dates, but I'm pretty sure that's what it is. Yeah.
Okay. Time is 6:30 to 9:30 p.m. Eastern, 3:30 to 6:30 p.m. Pacific. Registration deadline is February 1st, 2026. And you can find that on IHN's website as well. And the start is Tuesday, February 10th. That's when the session 1 starts.
And I'll tell you, not because I teach it, iridology itself is fascinating. I had a student come in today and she did some co-op hours with me because IHN requires people to do the co-op hours. They come in here for that because we're a partner with IHN for co-oping. And I had another lady in here. She's talking about iridology. She actually took the iridology class and she says, I loved it. I absolutely loved it. Not because I did it, because iridology itself is just a fascinating study. And I don't give homework. I don't give homework. You got enough on your plate right now. But we've now been able to teach European iridology, North American iridology. I teach pupil tonus. I teach sclerology and Rayid. There's all these different forms of iridology or analyzing of the eye on that one course. That's probably, I gathered all this information to make it one of the most comprehensive iridology classes you can take in North America. I'm not saying that to boast or put myself on a pedestal. I'm just saying I did that for the students so you get a combination of a lot of different ways and you'll be able to do everything I did tonight and a lot more just from that one class or from that one course. So it's well worth it.
Well, thank you once again for sharing your deep knowledge and expertise with us today. It's always such a pleasure having you, and this was such an interesting and inspiring topic. So just a little, Rob, if you have anything else you want to mention, please go ahead.
No, I think we covered everything tonight, but anything that you need, any questions you get, you can also get it through IHN. They have all the details upcoming, everything as far as courses and what's needed, registration, anything like that. So you're more than happy to talk to them. And hopefully you'll join us in the next iridology course. We always have a good time. It's a fun time. What I actually do in this class is I ask everybody to send in their eye photos. And we put it up on the screen and everybody can, and I have the other students do your own analysis so they can prove to themselves how much they've learned and you'll know if they're right or not. So it's a fun time. We'll actually, we'll cover all these different types of iridology, but you'll actually have your iris analyzed as well. So hopefully you can join us. Thank you again for joining me and why I'm so passionate about this. It's a fabulous science. So hopefully we see you then.
Wonderful. Thank you again, Rob. Thank you, everyone, for joining us today. If you'd like to learn more about IHN or explore our programs, we invite you to book a one-on-one advising session with one of our program advisors like myself. Have a great evening, everyone, and we look forward to seeing you at the next IHN webinar.
Thank you.
Thanks, Rob.
Take care.
All the best.